16u cubed v to the minus 3. Now, somewhere in your worksheet, it probably says, you might have heard this in class, no negative exponents.
Yeah.
Sounds very harsh, but that's the whole point of this, is to follow the rules. So anything to a negative exponent ends up being 1 over the same thing to the positive exponent.
All right.
So this v to the minus 3 is really 1 over v to the power of 3. So
All
this
right.
becomes 16u cubed on top over v cubed on bottom.
All right.
Any questions, thoughts on that?
No, I'm all right.
Okay. So there's about 10 rules to know on that sheet, and they all come into play in different situations here. So then there's kind of no order of operations. It's kind of like whatever you see. Like if you're like, oh, hey, I see 4 times 3. You can do that first. That's 12 times y, x to the minus 1, y to the power of 2. What is the exponent above y when it's not written?
1.
It's a 1. And you might think to write that. So the next property is that when the bases are the same and you're multiplying, you add the exponents. So I'm just going to rewrite this here. The y's are the same. That's the bases. You add the exponents. So this part right here becomes y to the 1 plus 2, or the y to the power of 3. Does that make sense? Sound reasonable to you?
Yeah.
All right. And then this x to the negative 1, just like in the previous problem, it's really 1 over x to the power of 1.
All right.
So it's 12 times 1 over x to the 1 times y cubed. And you multiply the tops, you keep the bottom. 12y cubed over x.
All right.
Any thoughts on that?
No,
Questions? Okay.
no questions.
And I'm doing this very what's the right word? I'm trying not to combine any steps. I'm really trying to do this very deliberately. That's the right word. So just keep that in mind.
Mm-hmm.
Uh, what is n to the power of 0?
1.
It's 1. So you've got an m cubed times an m to the power of 1, n cubed. What happens when the bases are the same and you're multiplying? What do you do to the exponents?
You add them.
Add them. And it's customary to put it in alphabetical order
All right.
if there is a preference.
Okay.
Okay. So that's kind of like the basics, and then you now get into the more complicated stuff. Probably just the moment you feel like you're getting it, they add something different.
Yeah.
Okay, so you've got an x to the minus 4 and an x to the minus 2. When you add the exponents, what does that become?
-6.
-6. And then this y cubed and y cubed, when you add the exponents, don't multiply, add them, what does it become?
Y6.
y6. X to the minus 6 is really 1 over x to the 6th. Is that clear?
Yeah.
All right. And then this becomes 3 times 1 over x to the 6th, y to the 6th. So the top is 3y to the 6th over x to the 6th, like that.
All right.
All right. I want you to just try number 10. Let's give you a minute here. Just see what you can do with it.
All right.
And, I'll definitely jump in and help here, but take a look at that.
I got 9 over y squared.
You are correct. Very good. Very, very good. Okay. So I think you're getting it. I think you're understanding.
Yeah.
All right. So, all right, lesson over, right? Number 11 or 11,
Yeah.
unfortunately, it's just, it gets more difficult. So the
Mhm.
next property is that if you have like A to the M, B to the M, C to the uh, L, all to the power of X, you end up multiplying the exponent by X. So it's A to the N times X, B to the M times X, C to the L times X. So this two on the outside multiplies every single thing. M to the fourth, N to the minus six, T to the minus two. Could you tell me what the final answer is with no negative exponents?
Is it n to the fourth over n to the eighth?
These are not the same. N and P are different, so you cannot combine those.
Sorry, I miswrote it. Like n to the sixth, p to the second.
Yeah, very good. Okay. All right. So number 12 is similar. I'll try not to ask you too much. Maybe it's tough to talk right now. Um, there is an exponent above two. It's a one. And when you're learning this for the first time, it's really a good idea to like write it just to make sure you show that each of those get this 2 cubed, h to the 12th, j to the minus 3 power. So the final answer here is 8. That's 2 times 2 times 2, h to the 12th over j to the power of 3. Does that make sense?
Yeah.
Okay. I want you to try 14, but I want you to ignore the negative for the moment. Just treat it like just ignore it. Just pretend like it's not there. Could you
All right.
talk about what to do with that? But could you give this one a try, please?
Sure. I got z to the sixth over x to the third, y to the 12th.
All right, very good. Now we're gonna go back and I'm gonna do 13, and then we'll talk about how to do 14 or the little negative thing, see how that matters.
Mhm.
Um, actually, hang on. So I'm trying to avoid negative exponents. It doesn't look like I can much further. All right. Um, all right. What is the exponent above 3?
1.
Same with the z. So it's negative 3 goes to each of those. So it's 3 to the negative 3 power, z to the negative 3 power, x to the 6 power. Is that okay so far?
Yeah.
All right. Now we've done enough of these that I hope you know to write 1 over 3 cubed, 1 over z cubed.
Mm-hmm.
Is that okay?
Yeah.
All right. X to the 6 stays. So your final answer here is x to the 6, 27 z cubed. So I'm going to give you one to think about here, kind of like this. Let's go. Let's go. Negative. Sorry, 4x to the minus 2 y cubed to the power of negative 2.
All right. I got x to the fourth over 16, y to the sixth.
Good, very good. Okay, so back to 14. Um, the everything we did was correct, but what I would suggest here is when you see a negative here is you call it -1. the power of 1, x to the negative 1, y to the negative fourth, z to the 2. And so when you raise it to the power of 3, it's really important that it's actually in parentheses here. You are doing just like we did before. So it's really negative 1 to the power of 3. And as a reminder, negative 1 to an odd power is negative 1. Negative 1 to an even power is positive 1.
All right.
You might be wondering, why is he even bringing that up? Because it's easy to get the wrong sign. Just totally is easy to get the wrong sign. So I want you to treat that like it's a number and move on from there. Any questions on any of that before we continue?
No, I don't think so.
Okay. So why don't you try 15 and then we'll talk about some more rules.
All right. Is 15 -1?
So tell me what you did to get negative 1. What did you do first?
I did h to the 0 power is 1, but the like to the negative third power, if it's odd, it's negative, right?
So 1 to any power is always 1.
Yeah,
So you
but
have 1 to the negative 3 power. It's negative 1 to an odd is negative
uh,
1. Negative 1 to an even is 1.
wait, what if like one's to a negative power, it doesn't change, it's just 1?
1 to any power is always 1. Doesn't matter what it is,
All right.
any power. All right. There's a there's a few other rules that we have not talked about that would matter here for the next 5 questions. So I guess I'll cover those now. So we talked about this idea that if it's like x to the -2, this is 1 over x squared. But what if it's 1 over x to the -3? Are you surprised that this becomes x cubed?
No, because it like switches the side, right?
Exactly. Switches position, flips from top to bottom. So you see that here and I'll look at a problem like 16. There's a couple of ways to do 16. I'll just show you, one way to do it. So one way that students do it is they immediately deal with the negative exponents. So they say, okay, this m to the -2, that goes to the bottom. M to the -1 goes up top. Okay, p cubed, p, q to the 0 stays, and then the q to the -1, it goes to the top, q to the 1. That's one way to do it.
All right.
All right. So that's way number one. So we'll just follow this a little bit here. So new rule, when the bases are the same and you're dividing, you subtract the exponents. But whatever you get, the result goes in the numerator. Okay, so like this first one here, 1 minus 2. What is 1 minus 2?
-2.
Try again.
Oh, sorry, -1.
Yeah, that goes in the numerator.
All
How
right.
about 3 minus 1?
2.
So that goes in it always goes in the numerator, p squared. And then q to the 0 is 1, q to the 1 remains. So where does this m to the -1 need to go?
On the bottom.
On the bottom. Yes, the final answer here is 2p squared q over 3m.
All right.
So I'd like you to try number 19, believe it or not, doing what we just did, which is moving the exponents, or moving them from top to bottom or bottom to top if they're negative, only if they're negative.
All right. I got 2p 5q 6 over 4.
Like that?
P to the fifth.
Yeah, so yes, okay. Yeah, good.
Yeah.
Okay, I didn't hear you, or you did say it and I didn't hear whatever. Good job.
It's fine.
Now, you do have to deal with the numbers out in front. We didn't talk about that. They're both divisible by 2, so you divide them both by 2.
All
You
right.
get p to the 5th, q to the 6th over 2 like that. Okay, so let's look at 17, and I'm going to give you option number 2. So
Okay.
there's more than one way to do problem, and you get to decide. It's up to you. So this one, we're going to work using the subtracting the exponents first. So this is 0 minus 3. So this becomes p to the minus 3 power. This is 0 minus a minus 1, which becomes q to the power of 1. And then this is 2 minus 2. This is r to the power of 0. So that is the other option, is to literally just subtract the exponents, or you can move them, your choice. From here, you know that the two negatives cancel. The p goes down to the bottom, q stays up top, and r to the 0th becomes 1. Is that okay?
Yeah.
All right.
Wait, wait, why is it not negative again? Like, why is it positive 2b squared? I mean, cubed?
The two negatives combine, these two negatives.
Oh, all right.
Is that reasonable or not?
No, yeah, it is. I just
Okay.
didn't realize.
All right. You're doing really well. I know you're not feeling well, but you
Yeah,
seem to be getting this
sorry.
done. I'm sorry to keep asking you questions, but we got to make this a little interactive here. So,
Oh,
um, why don't you try this one on your own and see what you come up with?
all right. I got x squared z squared over y to the fifth.
Like this?
Yeah.
Okay. So the x's I agree with, the y's I agree with, and the z's. This negative though comes with it as well.
Oh, oh, my bad.
Very, very good though. So another kind of way to do problems here, and I'm gonna kind of start 20, but not finish it, is to just like organize it sort of in columns, like it's 4 over negative 2, h cubed over h squared. J doesn't go with anything. K to the minus 3 over k squared. That's another kind of way to do these problems. And then again, you can sort of decide, okay, I'm going to flip it or switch it, or I'm going to just subtract. It's totally up to you. Um, so go ahead and give this one a try, and let me know what you come up with.
I got negative 2h over j k to the seventh.
Negative 2h over j could be k to the 5th on the bottom.
Oh, oh,
Minus 3, minus 2, minus 5.
my bad. I missed with the five as a seven, I think, or something, or I don't know. I thought three as a five.
Yeah, my handwriting is very poor sometimes, and I should do better. Um,
Ugh, sorry.
right up there with doctors as far as disinterest in writing.
Oh goodness.
Okay, Now they do get more difficult. So why don't I just give you one or two more problems like these, not getting into new stuff. Is that okay? Or do you
Oh yeah,
want to
that's
stop
fine.
here? Or do
That's
you want to,
fine.
yeah. Okay. All right, go ahead and work this one out, please.
All right. Is it x to the fifth and y to the seventh?
All right, so you might be wondering why I did that. So I'm going to give you a really, really similar problem here.
All right. Is it 1 over xy?
That's what I wasn't sure if you would know how to handle that. Um, so good job on that. Now, these do get more complicated, and we don't have time to get into those, but what you might have seen in your class or it, would be basically like a problem like I'll just snip in 20 as an example. And what they do is um, they give you something like this, but then they throw it to like the -5 power.
Yeah.
That's where you're going. And then they'll make it more complicated by putting another thing over here like 2hj over k to the -1 power. And so that's where you're going. But they're essentially problems like we've been doing. Um, so that would be something to tackle, another time. But I appreciate the effort. This is a great example of why Zoom lessons are so productive. You can still do them even if you're not feeling well and
Hmm.
still get something out of them. So good job today. We're gonna go ahead and stop there.